Thanks for joining us, everyone. As always, we always appreciate everyone joining and participating. Welcome to the Pittsburgh Jug. Like always, you can follow us on Twitter. Everyone here already knows about the meetup, but if you don't, go there. But you kind of had to go there to join anyway. We have a few announcements. First of all, we do have a YouTube channel. We have all of our 2021 presentations up there, and we're uploading all of the presentations from this year as they happen. So today's presentation will be uploaded either this weekend or the upcoming week, and they'll always be there. And if you search for Pittsburgh Jug on YouTube, it should be the first result. And we have two upcoming presentations that we want to talk about. On May 12th, we're going to have a presentation from Dawn, and then in June from Anna Maria. And we actually have some exciting news to share. We want to thank JFrog for being our first official sponsor. It's been a long time coming, but we're very happy. And yeah, thank you, JFrog. And on that note, we're going to turn it over to Melissa. I'll let you introduce yourself because it's always better from the person, but yeah, feel free to share and get started.
Hi, everyone. Really glad to see you all there in Pittsburgh.
Yay.
Yes. So one of the positive things about doing these virtual things is I get to go anywhere now and I get to meet all kinds of new people in different places, and didn't have that opportunity as much before. So this is really cool. Anyway, yeah, I'm Melissa McKay. I do work for JFrog. I'm a developer advocate, and I've been there about 2 years now. And in fact, I'm going to go ahead and start sharing my slides here with you. Mm-hmm. And go ahead and get into introductions. Okay, cool. You should be able to see that now. I'm going to be talking to you today about containers, crash course in virtualized container technology. And before I go any further and get into more about my background and stuff, Ari Waller, he is JFrog's meetup manager. He always likes to put these on for any of the talks that we do for any of the meetup groups. We have a raffle. So if you go to this link here, you will be able to not only see the slides that I'm presenting today, they'll all be there, but you can also enter a raffle for the Amazon Echo Show 8. Now, you will have a high chance of getting this. So go ahead and enter that. And you'll be notified in the next 3 business days. Ari will let you know and then post it in the meetup group as well. So yeah, don't miss out on that. Okay, so yes, as I said, I am a developer advocate. Prior to that, however, I was a developer all the way from an intern to a principal engineer for about 20 years of doing that. I remember the very first project I worked on as an intern was a Ruby on Rails project. By the end of my career, I was mostly in Java server-side applications, a lot of web applications as well. Toward the end there, I started speaking publicly. That came about just by, interesting circumstances and opportunities that just happened to coincide at the same time. I ended up meeting some amazing people at an unconference. If you've never had a chance to visit or participate in an unconference, it is an informal conference, very different than the formal conferences where you have a speaker standing up and you have all of your audience listening. Anyway, this particular unconference met some pretty incredible people who really shepherded me and helped me get my career moving as far as a speaker and sharing knowledge and teaching, that kind of stuff. Really exciting. Started doing that, decided I needed to find an actual position that where that's my job. So that's how JFrog came in. That's how becoming a developer advocate happened. I did become a Java champion at JFocus last year. Was it 2 years ago now? Time kind of blurs together the last 2 years. It was a virtual conference. I'll be heading to JFocus again in person this time next week, actually, and be able to see the people that gave me the award. Pretty exciting. I'm very excited about that. I did also become a Docker captain, so I am very much involved in Docker, what they're doing these days, the new features that they're putting out. They're putting out one, they'll announce the release and stuff. It's called Docker extensions. It's kind of fun to play with and see how that works. I've also learned a lot about wrapping Java in a container, and I'll talk to you about that journey a little bit too during this talk. Here is my Twitter handle. That's probably the best way to reach out to me is my Twitter handle. So feel free to do that. My DMs are open. If you have any questions or just want to reach out to me about this talk or any other that you see around, that would be welcome. All right, today we're just going to start with a brief history to give you some background context. Hopefully it's not too boring, but there's definitely certain milestones in there that are good to know to get a better understanding of how we got here today with images and containers and how we work with them now. We'll also take a look at the container market. I found that really interesting just to see how much it has grown over the past few years. Then we'll move into getting a real understanding of what Docker is. I am a Docker captain, but I don't, and I'll be talking a lot about Docker, but I do want you to understand there are other things out there besides Docker, and we will touch on that a little bit. Docker is not synonymous with containers. You can have images and containers that are not based on Docker. All right, then we'll talk more about what a container actually is, take a little tour of what it looks like on a Mac, for example. And then we'll review a few container gotchas. And then last but not least, I'll talk to you about managing your images and what you might want to consider when you start creating your own images and where, the decisions you need to make on where to put them. Okay, 2 reasons I'm showing you this slide. I'd just love to know how you are using containers today. For those of you that are here, just take a moment and throw in the Slack how you're using containers, or if you're using them at all. It's okay to say, no, we aren't there yet. We're not doing that. Or if you haven't considered it before, there are good reasons for using containers other than for production. Maybe you're just using them locally, or maybe you're just using them in your test environments. Maybe not so much in production yet. Just curious how that is. So yeah, Renat said she's using them locally, test QA and prod environments. So you've got it through the whole shebang there. You've got using containers. Cool. The top 2 listed here definitely, helps provide consistent development environments in testing and QA environments where you can still gauge the quality of your applications with significantly less resources than a full-on production environment. So they're helpful in those areas. All right, we have some, we have student, awesome. I love students. Recently did a Docker class at a college. It was my daughter's college, so I had an in. And that was a lot of fun teaching kids about Docker and how to build them. Yes, you have quite a future ahead of you. All right, and VJ also local test and prod environments. Cool, good to know. Okay, let's jump in and just start talking about containers. I'm sure that is not the graphic that you were expecting. I've given this talk a few times and I just enjoy this one. It's one of my favorites. You will not see a container talk from me that uses shipping containers. I'm just really bored with those. So I try to come up with some other theme or idea to work around. And this one, you get bananas. So hope you enjoy that. Okay, let's talk about how this all started. Way back, 50s and 60s, took a long time to get anything done on a computer. You had to share resources. It was just a lot more difficult to do that without causing problems for anyone else using the same machine. And obviously, limits on time and resources created some bottlenecks and inefficiency that we started to work on. And just being able to share was not enough. There needed to be a method of sharing without getting in each other's way or having one person inadvertently cause an entire system to crash for everyone. This need for better strategies in sharing compute resources actually started a path of innovation that we see massive benefits from today. And it's really interesting what's happening today. There are some key points in time that helped bring us here today with containers, and we're going to start with talking about Charoot. Charoot was born in 1979 during the development of the 7th edition of Unix, and it was added to BSD, the Berkeley software distribution, in 1982. And being able to change the apparent root directory for a process and its children, that's what Charoot gives you, results in a bit of isolation in order to provide an environment for testing a different distribution, for example. In fact, that's how it even made it in. It was a utility that was used to test different distributions and be isolated from the rest of the machine. Charoot was definitely a great idea, a good start in the right direction, but more was needed. And in 2000, the jail command was introduced by FreeBSD. Jail is a little bit more sophisticated than Charoot in that its additional features help to further isolate file systems, users, and networks, and also the ability to assign an IP address to each jail. That became important. In 2004, Solaris Zones brought us ahead even further by giving an application full user process and file system space and access to system hardware. And Solaris Zones also made popular this idea of being able to snapshot a file system. In 2006, Google jumped in with their process containers, and these were later renamed C groups, which you may have heard of, that centered around isolating and limiting the resource usage of a process. Moving right along in 2008, C groups were merged into the Linux kernel, which along with Linux namespaces, that led to IBM's development of Linux containers. 2013 was a big year. Docker came on the scene, bringing their ability to package containers and move them from one environment to another. And the same year, Google open sourced their Let Me Container That For You project, which provided applications the ability to create and manage their own subcontainers. And from here, we saw the use of containers and Docker specifically explode. In 2014, Docker chose to swap out their use of the LXC toolset for launching containers with libcontainer in order to utilize a native Golang solution. Now you can actually go to GitHub and you can find libcontainer. That is there. You can see, what's happening in there. And I'm almost done with this history lesson. This is a lot to throw at you. I'm skipping over, some details. There's a lot of different projects and organizations and specs that came out during this period of time too, but something happened in June of 2015 that I really want to get to. This event is important to know about because it will give you some more insight into some of the activity and motivations behind shifts in the market. The Open Container Initiative was established. This is an organization that is under the Linux Foundation. It's active still. It includes members from many major stakeholders, including Docker, with the goal of creating open standards for container runtimes and image specification. Even more stuff happened, still happening. But there are a couple of other dates that are also going to be important specifically to Java devs and for us to know about specifically. One is that Java 7 was released in July of 2011, and work was started on Java 8, which was released in March of 2014. Keep that in mind because when you start containerizing your Java applications, this little bit of history will be important to know, and I'll bring it up again later. And that's it for our history lesson. I know that was a lot. What I really want to do to get out of this is the information about the OCI, how the Java development has interleaved with Docker development, and just the fact that this is not new. Containers and images have been around for a long time. Okay, let's jump into the market and see what's happened there over the last few years. This is more interesting information. I did a little bit of hunting just to find, some consistent data to look at, and I did find a report by Sysdig. Some of you might already be familiar with this company. They provide a really powerful monitoring and troubleshooting tool for Linux. They put out this container report based on analysis of their own users. And part of that report includes data on container runtimes that are used. So that means people that are actually running containers in production, what runtime did they choose for their applications? And in 2017, they analyzed data from 45,000 containers. There's no graph available for that one because 99% of those were Docker, so they didn't bother splitting up those results. In 2018, they analyzed data from 90,000 containers. Now we're getting a little more useful data, double the sample size. 83% were Docker, and then you can see there's a smattering of CoreOS, Mesos, and LXC. So it does look like some other container runtimes are starting to encroach a little bit on Docker. Moving on to 2019, the Sysdig container report included stats from over 2 million containers. So you can see just how popular this movement is. There are reasons for that, and we'll talk about those in a minute. Docker is still holding relatively strong at 79%, but take a look at that 18% of containerd. Note that containerd is actually a runtime that Docker builds on top of now. They contributed that project. So they're kind of one and the same. And then that last 4% is cryo. Notice that the disappearance of Rocket containers, that was kind of a sad story. CoreOS was acquired by Red Hat at the beginning of 2018. And prior to that, Rocket was accepted to the CNCF, the Cloud Native Computing Foundation, as an incubating project. And it looked like a really promising competitor to Docker's containerd. However, since that acquisition happened, the development of the project went dormant. I imagine they just didn't have the resources that they wanted to commit to developing that project any further or maintaining it. And in mid-2019, Rocket was archived by the CNCF. In February 2020, that project was ended. Now, it doesn't mean that you can't use a Rocket container if you wanted to. It's still available in the GitHub repo. You can still build one. You can still deploy them. It's just that no one is actively maintaining that project anymore. In January of 2021, Sysdig came out with their 2021 Container Security and Usage Report. It's hard to know if we're comparing apples to apples here, considering that little qualifier there of a subset of customer containers starting to mess with their sources of data a little bit. But this report includes a ton of detailed information about their demographics and data sources, as well as other interesting information about what services customers are running, as well as what they're using for their orchestration. In a nutshell, what I pulled from this report was this. Notice that increase in the usage of containerd from 18% to 33%. And it'll be interesting to see if that trend continues, which I assume it will, especially since Kubernetes announced a while ago now that they have deprecated support for Docker as a runtime later this year. That sounded terrifying to a lot of people at first when they heard that. It just means that Docker, as the huge tech stack and all of the extras that had to be put in order to be able to run it in Kubernetes, Docker broke apart their monolith basically, and now their runtime containerd, you can use that instead. So that makes sense, right? Containerd is rising, Docker is falling. All right, now that I've introduced some of these other container runtimes that exist out there besides Docker, we can take a look about what a container actually is. I do have one more report to show you though. This one is the most recent. This is also from Sysdig, of course. This was an analysis of 3 million containers, and we can see that we don't see a lot of change here. For any of these reports, all of the links are here on the slides if you wanted to go check them out. Like I said, there is a lot more interesting information in there to look at. I did find the information on orchestration interesting too, like how many are using Kubernetes versus other. What else is there besides Kubernetes? All right, what exactly is Docker? I did infer, in the beginning, Docker is more of a term that has been generalized, kind of like Kleenex. So just, it's used more often for containers and images that aren't really Docker container and images. So nice to know what the difference is and what Docker actually is. Docker as a company had over other players in this container game, they had a focus on commoditizing a complete solution that made it easy for developers to package and deploy their applications. And once containers became easy to use, we all witnessed that explosion of tools and resources around containers, and consequently, the increase in usage in production. The Docker image format rose to become a de facto standard in the market. And the stats that I showed from Sysdig are specific to container runtimes. That terminology is important to understand. We'll get into the pieces and parts involved in working with containers. You'll understand why Docker sucked up this market so fast. Okay, so we always need to go back to the problem we're trying to solve. And let's think about what we actually need to get our apps out there and running. As far as containers go, we just needed a way to be able to lift and shift our applications without a whole lot of effort. So in order to get that to happen, we need tools that allow us to perform those functions. So here's a list of needs that are broken up into discrete features. And first and foremost, we need that container itself. Some of you might be asking about virtual machines right now. Discussing VMs is out of the scope of this session, but one thing I will say is a virtual machine is not the same thing as a container. The biggest difference being that a VM includes an entire OS all to itself, and containers share the system's OS. The point of the container is to be lightweight and have the ability to move from one environment to another seamlessly and quickly. And that said, I know that there are some developments in the VM space, but that's a topic for another time. All right, so on top of the container, we also need a way to define the container. That's where we get the image format. We need a way to build an image of a container. We need a way to manage those images. We need a way to distribute and share those images with our colleagues and others. We need a way to create, launch, and run a container environment. And then we also need a way to manage the lifecycle of those running containers. And this doesn't even get into orchestration like that, like Kubernetes, those environments, but this is plenty to prove my point about Docker and why they became so popular. So in the context of those developer needs that we just went through, Docker was ready with an answer for everything. You want to start using containers? They provided Docker Engine. You need an image format? They had a Docker image format, which was actually contributed to the OCI. You need a way to build an image? Use a Docker file called Docker build. You want to manage images? You can call Docker images, Docker RM for remove. You want to share your images or use an image from someone else? You can call Docker push or Docker pull. And there's Docker Hub, where you can store and share your images. You need a way to launch, run, and manage your containers in their lifecycle. Call Docker run, Docker stop, or Docker PS. Docker quickly met the needs of a container-hungry market, especially for developers. They made it easy. This was just a full package and gave them a tremendous part of the market share out of the gate. So I hope you appreciate this banana graphic here. I was trying to find something relevant and all I could find was bananas and wedding rings. So there you go. Hope you enjoy that. All right, remember when I talked a little bit about the Open Container Initiative, the OCI? Out of all of those features that we just listed, that was discussed that Docker offers, There are two of them that were taken up for the cause right away by the OCI. That was the image format and the container runtime. Since then, they've also contributed distribution, which is the push and pull of images and how that works. So they have standards for that too. Docker did quite a bit of reorganizing their code base, and they developed abstractions, pulled out discrete functionality. They are a heavy contributor to the OCI. They gave the Docker v2 image spec as a basis for the OCI image spec. And they also gave run C, which that is a reference implementation of the OCI container runtime spec. There are quite a few other container runtimes you might see out there, including Containerd, Cryo, Kata, which is more VM-like, all of which all have various levels of features for specific use cases. Run C, just to clarify, there's low level and high level container runtimes. Run C is actually a low level container runtime that Containerd uses. Containerd actually was contributed by Docker to the Cloud Native Computing Foundation. It internally runs Run C. It was integrated into Docker and has been in use in Docker since version 1.11. That came out way back in 2016, so it's been a while now. The next few years are going to be interesting to observe what happens with the specs and how the OCI moves forward. There was quite a bit of period of time between the original image specs and then the distribution spec that came out. It turns out that it's difficult to come up with standards. And I've been on a few like special interest groups now where, we might spend quite a while deciding, whether our verbiage is correct or whether we're using the right terminology. So it takes a while, not only in that respect, but there's quite a range of differing opinions about what should and should not be in the standard for a container runtime. And we're in a situation right now where just having the runtime that just meets the requirements of the OCI, it doesn't seem to be enough to drive adoption. I've added a couple of links here. They're excellent starting places to learn more about container runtimes and dive in deeper if you're curious. That second one is the beginning of a blog series by Ian Lewis. It's aged now, but it's still relevant. It's still a very good explanation. He's a Google Dev advocate, and the first subtitle in that blog is titled, "Why Are Container Runtimes So Confusing?" And so he takes that and really tries to explain succinctly why that is and how they actually work. All right. Now that we understand what Docker entails and what's going on in the market, let's focus just on the container itself and what it looks like on your system. I'll show you how it's being stored on my Mac because that's what I'm working on. But you'll discover pretty quickly that images and containers aren't really all that magical. Okay, my first experience with containers, it was several years ago. I was a developer on a new project. There was a tight deadline, of course, and I could argue that's a good description of most projects. Everyone always has a tight deadline. But the best course of action for me was just to jump in and start getting something up and running on my local machine. Now, it was really good to start with this particular project because it was from a third party. They had originally developed this project and now it was bringing in, brought in internally to the company, and now it was our responsibility to add features to it and maintain it. So it wasn't like I needed to start from scratch. I could just look and see what was there and start learning that way, which was good. The Docker documentation too is actually really good. So if you find yourself in a similar position, recommend go directly to their Getting Started docs. I've linked to those here. They have some pretty good ones about Java too, but I really encourage you to question everything that you see about Java and just about building images in general. A lot of examples are meant to be just that, just examples. They are not always production worthy. And by the end of this talk, you'll understand why that is. The first thing to note is that a Docker image itself is really just a tarball of the complete file system. And an image, just to be clear, an image is like a blueprint, equivalent to like a class file in Java. And then a container is an implementation of that. It's an object created from that blueprint. So you could have multiple containers that come from the same image. So the image is where you need to start. Learn how that image is built. When an image is unpacked, like when it's about to be launched into a container, it's actually just thrown into its own directory, and that becomes the root file system of that container. The second thing to note is that processes that are involved in running the containers are just regular Linux processes. In fact, in the Docker documentation itself, you'll find a really cool video about creating a container from scratch using Go. And it really makes it plain that these are not magic. They're just, Linux processes. There's just a few Linux features that are used together in a way to achieve the isolation that we want from containers. Namespaces are they're an important ingredient. They are used to provide virtual separation between containers, ones that are running on the same host, for example. This is how processes inside one container don't interfere with the host itself or processes inside another container. And here you can see an example of just some namespaces that were set up when I launched a Postgres container on my box. The C groups functionality is essential to constraining how much a container can use things like CPU, memory, network, bandwidth, etc. I can set up these constraints by including options on the Docker run command when I'm launching an image. Here you can see that I've constrained my memory usage limit on one of my containers. I'm going to quickly gloss over some file system details where containers and images are actually stored on your file system. First off, after you've installed Docker, running the Docker command, excuse me. Running the Docker command info will spit out a bunch of information about your installation, including the Docker root directory. And this is where you're going to care about the most. This is where everything regarding your Docker images and containers is going to be stored. If you're on a Mac, like me, your containers are going to actually be excuse me.
Fine, take your time.
Losing my voice.
Take your time.
Yeah. We can see that. We can see that. I can fill up the silence for a while. Take your time.
Okay.
You feeling good now? Okay. Just when we were about to say, yes, this is it. Yeah, but anyway, if all those who joined in the last few minutes, I've pasted a link in the chat. You can go there and you can find all the slides and also a chance to win Amazon Echo. So, and the chances of one of you winning is pretty high. So go take, go try your luck out today for sure. But yeah, that's JFrog sponsored. So that's pretty cool.
Awesome. All right, let's see if I can keep going here.
Okay.
Recover my little voice box.
Yeah.
All right, so we were talking about the root directory, where everything you're going to care about regarding your Docker images and containers is going to be stored. Now, like I said, on the Mac, you run in a tiny VM, so you're going to need to use some type of utility to get in there and get to that Docker root directory to look around. I posted a couple commands in here. One is to use a container itself and launch it in such a way that you can actually navigate to that directory to take a look at it. And I did it for Windows too. I feel bad because I'm always coming from a Mac and I don't disregard Windows users quite often, so I apologize for that. I stole my son's machine. It's a Windows machine, and I installed Docker on it, played around with it for a while to see how it looked. This was the directory that I found the Docker images in on the Windows machine. By the way, I really like the new Windows, that has the Linux included, so that you can actually run Ubuntu, for example, on your Windows box. Pretty cool. how that works. Almost convinced me to buy a Windows machine just to check it out. All right, this slide shows how you can get information about the images that you have stored on your system. First, I listed my available images using the Docker images command, and I actually have several installed, but I'm just listing the first couple. Using the Docker inspect command, you can inspect any image you like using its image ID. This will spit out a ton of interesting information. I just want to highlight here the graph driver section, which contains the paths to the directories where all of the layers that belong to this image live. Docker images are composed of layers. I'm sure you've heard that before. That represents instructions in the Docker file that was used to build the image originally. The layers themselves, the commands, actually translate into individual directories. And these layers can be shared across images in order to save space on your machine. Each layer, subsequent layers they are consisting of the differences between the previous layer and the new stuff that has been added. The lower dir, merge dir, and upper dir sections here, those are also important to take a look at. The lower dir directory, and you can navigate to all these, by the way. If you're in that root directory, you can navigate there and check them out. The lower dir directory contains all of the directories or layers that were used to build the original image, and these are read-only. The upper dir directory contains all of the content that has been modified while your container is running. So if modifications are needed for a read-only layer in lower dir, then that layer is copied into the upper dir where it can be written to. And this is called a copy on write operation. It's important to remember that the data in upper dir is ephemeral data. It only lives as long as the container lives. In fact, if you have data that you want to keep, that your application generates, for example, that includes, logs, things like that, or database, stuff like that, you should utilize the volume feature of Docker, mount a location that will stick around even after that container dies. Ship your logs out from your container because they are intended to be short-lived. And this is how most containers, running a database as well will operate. Lastly, the merged dir is kind of like a virtual directory that combines everything from the lower dir and the upper dir. And that's the way the union file system works. The edited layers that were copied into upper dir will overlay the layers in the lower dir. If you were to actually exec into the container, and so that you're inside of it and look around, that is the layer that you're looking at, the merged dir. Okay, this slide shows I had a few running containers on my system. Two of them were a local JFrog container registry installation I was playing with. It included a container for Artifactory and a container for a Postgres database. The other was just a simple test container I was playing around with just to see how it worked. Note that the container IDs of the running containers actually match up with the container subdirectory names. Something to remember here is if you stop a container, that corresponding directory doesn't automatically go away until the container is actually removed with the docker rm command. So if you have stopped containers lying around that never get cleaned up, you might see your available space to start to dwindle. Docker volumes is another one. Those will also accumulate on your system. That happened to me almost right away when I started working with containers. I didn't realize that you can't just keep launching containers and without dealing with them and cleaning them up. And they get pretty big pretty fast. There is a Docker system prune command that you can run every now and then to help clean things up. It will not clean up volumes by default. There's a flag that you have to include if you want to clean up volumes as well. Or you can launch a container with a flag to indicate that it should be removed when it's finished running. A lot of orchestration will take care of this for you as well. So if you have a, if you're using Kubernetes or something, you can indicate that you want your containers to be removed when they're done. So the tool sets around building and running images and containers have made things so easy now that it's also easy to shoot yourself in the foot. And I'm going to go over some of the most common gotchas, the ones that I ran into right away, including some JVM specific gotchas that Java developers will care about. Those I also ran into almost immediately when I started working with them. The Docker file. Hard to work with Docker without looking at, seeing, manipulating, getting angry with the Docker file. With that Docker file, you have all the building blocks you could possibly need to get your application out the door and into production. This is a fairly exhaustive list of the commands that are available to you in a Docker file. With these, you can pretty much do anything your heart desires. You can do all the right things, and you can also do all the wrong things and everything in between. It's deceptively simple. The first is running a containerized application as the root user. And I'll be honest here, when I was initially getting containers up and running, I was just so happy that it was working. It was a while before I took this one seriously. And it once you understand that the processes inside a running container are just like any other process on the system, albeit a few constraints, it's scary now to run as root inside a container. Doing that opens up the possibility of a process escaping the intended confines of the container and gaining access to host resources. What that means is if anyone were to find access to your container, be able to exec inside your container, and they immediately have root privileges, they can really mess with your host, not just the container. So reduce the attack surface of your container by following the principle of least privilege. And although containers are designed not to affect other running containers, if someone gains access to it, obviously they can immediately cause you some problems. How do you mitigate? Obviously, don't run as root. Best thing to do is create a user, and you can use the user command inside a Docker file when the container is built in order to run processes as that user. If you look at Docker files from a lot of official Docker images, you'll find that that is exactly what's happening. For example, I think the last time I looked at the Postgres one, you could open it up and you can see that they're setting up a user and running it as a Postgres user. There is also a way to specify a user when you're using the Docker run command, like when you're just launching the image from Docker run. But that leaves open the possibility of forgetting to do that. So I like it better to have it inside the Docker file so you don't forget. Also, I just mentioned the Postgres official image from Docker Hub, but pay attention to any official image that you pull from Docker Hub, any image at all, actually, whether or not they run as root by default, and they could be letting you, figure that out when you're building on top of the base image. So pay attention to what's going on there. Docker official images, I mentioned those. Those are a curated set of images. A dedicated team at Docker is responsible for reviewing and publishing those. That's done in a very transparent manner, and it's very easy to take all that for granted. But of course, if you use any of those official images, stop and take a look at their original Docker files. If you remind me after this talk and you're interested, I can show you where to find those as well. The link here that I have here, well, that's it. That's how you find them. But I can show you some more details of where to go in there. That is the official repository that Docker uses for all of the official images that they have. The files in there, they contain a path to the corresponding GitHub repo for that image, and that's where you can find the Docker file. All right, no constraints. Even though Docker provides you with the ability to set resource limits on your container, it doesn't automatically do that for you. In fact, the settings are pretty much a free-for-all with no limits anywhere. So make sure you understand the resource needs of your application. Just because you can now wrap your application inside of an image. It doesn't mean that you can be lazy and not understand the resource needs of your application. You can use, you're going to want to monitor this over time. So setting up monitoring on your containers, your running containers is important, and adjust resources as needed. That is a very good way to determine if something's going wrong, like if load on your system has suddenly changed. It's very valuable information and a must do. You can also use that information to determine if your application should be split up further. That actually happened with us. It wasn't a huge monolith, but there were a couple pieces that we needed to scale differently. So we were able to break it apart and make a lot of progress that way. All right, never updating. This is a very big security issue. It's very easy to get complacent and not pay attention to what's actually getting pulled in when you build images. Not only do you need to be aware of outdated versions that you specify in your Docker file, but you need to pay attention to what's in the base image that it's coming from. Now, images can be built in a hierarchical fashion. So you can have a parent image, and when you look at that parent image's Docker file, it could also have a parent image, and that can go all the way to the very beginning until you find a Docker file where the first line in the Docker file says scratch. That is your base image. So not updating packages and libraries too inside those images. Those can cause you some issues. And ensuring that you're running containers with a non-privileged user, also even that has risk if there's known vulnerabilities that exist within your container or even the kernel of the host. So from time to time, exploits are found that enable attackers to potentially escape the container. Definitely keep up with those security updates. I've definitely also been on teams where that is not a priority. And usually it's because of the fear of breaking something that is working. That's just a symptom of different issues. It's much worse to let those vulnerabilities sit there. I remember a team that did have some problems with bit mining and stuff, and luckily they had everything monitored so they could tell immediately when resource usage started going through the roof. They were able to figure out what was going on pretty quickly and fix it. Image bloat. Like I said, images can get pretty big pretty fast, especially if you have, images upon images upon images. Sometimes it's not all obvious what all's in there when you're looking at a Docker file that's down at the bottom, right? But when it's finally up to you to start adding your own packages. So one thing to do right away is start making sure that you're using the .docker ignore file. It works very much the same as git ignore. Prevents you from adding things like unit tests or secrets even that you really shouldn't be adding, extra resources and stuff other than what you absolutely need to run your application. Only move into that image what you need, nothing more than that. One thing that I hadn't thought about until much later is you need to, don't move in your whole Git directory into your image. If you're doing one of these Docker files that just does a full-on copy of everything, think about what all that means, what you're actually copying in. This isn't limited to Java projects either. Any project, you should pay attention to that. Another mitigation is to use the Docker's multi-stage Docker build. I can show an example of that in a moment. That way you can actually do your build and everything, pull in all of your third-party dependencies or other dependencies during your build, and then only copy in the artifacts that were produced from that build into a second stage. That'll help limit the size quite a bit. Okay, this one is Java specific, specific to containerizing Java applications, and very related to being aware of what your application requires to successfully run with the memory it's been allocated. The JVM is pretty clever at determining settings for your swap and heap and your garbage collection behavior based on things like the memory and the number of cores available on the host. Remember our history lesson, that interleaving with Java 7 and Java 8, and along with Docker development. Considering that timeline, Java 7 and I don't know anyone on Java 7 still, but I do know a lot of people still on Java 8. They're not fully container aware. This means that your Java application won't necessarily obey memory and CPU constraints that you put on your container, and you might end up with some out of memory killer activity. The reason for that is because the mechanisms that the JVM used in these older versions to retrieve the resources available come from the actual host machine and not the C groups limit that you would expect. There were some improvements around container awareness that were introduced in Java 8. Later updates, I think 131, and then further improvements in later versions. But to really get all of the benefits of container awareness, you really should try to get to 11. That's the earliest LTS release that is container aware. All right, Distro List. This is another option for you to choose. Distro List images, there's some that are available by Google. I believe they have 11 and 17 now. These are images that really slim down what you absolutely need to run in your image. In fact, they don't even include a shell, which means you can't even exec into the image when it's running, or when it's running as a container. That definitely helps with your security, makes troubleshooting a little more difficult, but you really shouldn't be execing into production running containers anyway. So it encourages you to use best practices like shipping your logs out, things like that to do your troubleshooting for running containers. This also shows you an example of multi-stage build. So you can do all of your build like in this example at the top, and then the second section starting in line 7, you get a second from statement. That's the distro list image. And then only the items that you need are copied in. There's a link here, lots of more information on distro list containers if you're interested. Other methods, you can make your own custom image. This will really slim down Java projects and Java images. You can use JLink that is packaged with OpenJDK 11. What that allows you to do in combination with JDeps is figure out exactly what dependencies you need to run your application and only include those in the image, in the base image. You might find this will help a Spring Boot project out quite a bit because that particular framework brings in a ton of stuff. So you might find some benefits there regarding the size of your containers. Reason we care about size of containers is think about, every time you need that container to launch and run, you've got to pull it from a registry and get it started. So I'm not really talking about the start time, but more about transfer time, getting that thing where it needs to be in order to get launched. There's a Maven and Gradle Spring Boot plugin. This allows you to avoid having to worry about the internals of Docker or building Docker files. But think of all the things we just learned about Docker files and how you can help yourself. So if you choose to use one of these methods, I would encourage you to pay attention to what's actually being produced. One thing about the Maven and Gradle Spring Boot plugin, for example, is it actually uses build packs. And when I used it, it uses Paketo build packs. That means it's pulling an image and which determines how to build your application. It does things like look at the format, it, figures out, oh, this is a Maven project, we'll build an image this particular way. But just note that that's what it's doing behind the scenes. It's pulling an image from somewhere else. So once again, you're relying on an external resource. You might want to pull those down, store those somewhere, and then set up your Maven or Gradle plugin to use your build packs that you have stored so they don't get changed out from under you. We talked about build packs a little bit. You can find out more about those from these links. And then there's Jib. Jib, the pro there, it's simple. You just add the plugin, but it also builds and pushes your image. Supposedly that's good because it reduces the number of steps, but I find that kind of weird to do as a developer, to be pushing images anywhere. You really should only be checking code into GitHub, and then your CI process would be building images and taking care of that. So I don't particularly like that idea of pushing images. Also, some defaults might not be what you want. Jib, Distro List base image is often assumed. And then, of course, since it's pushing images, you might have to troubleshoot auth issues with those private repositories. If you don't want to use Docker at all, if you're on a Linux box, you've got some other options. You can go check out Podman and Builda. They are not as easy to use on Windows and Mac development machines, but if you're in Linux, or if you're more involved in operations, this might be the preferred method as opposed to using Docker. And the rest of this I'll go through pretty quickly. I do have a link here for just information on what to think about, what to consider when you're managing your images, where to put them, think about how you want to store them, how you want to protect them, whether you should be using a public repository or registry or private. JFrog obviously has a free version that you can try if you wanted to see what that's like. Also, just note that when you're pulling in base images, when you already know that your application is relying on a base image, pull those in and own them. Pull them in, tag them, put them in your private registry so that you know that it's not being changed out from under you for future builds. And that's it. That is all that I had to share with you. I didn't leave you any time for questions, but I can stick around a little longer if any of you want to chat a little bit more or take a look at a couple of different things.
Awesome. Sounds good. Yeah. And you guys can leave your questions in the chat, or if you want to, you can also unmute and ask them. I actually had a question about the container market slides. I think between 2018 and 2019, it went from like 90,000 to 2 million. I just wanted to see if if that was an actual huge increase, or was the scope of what they were looking at also increasing, or a little bit of both?
Yeah, it could be a little bit of both. I mean, because like I said, Sysdig was only looking at their clients too. So it could be that they had an explosion of usage, using Sysdig as well. I do like to look at the dates of like when Docker came out and what they were doing. I mean, the moment that it became, really easy for developers to start building their own images, it seems like we went pretty quickly from that to images starting to show up in production.
Yeah, that makes sense.
I have something interesting.
Okay.
Actually, I forgot about it and I just remembered. My friend, Ben Evans, he's another Java champion. He was doing some research on running Java and single core containers. This is an article here. I'm gonna grab the link and just put it in the chat. He discovered something interesting that, when we're building these containers, we tend to make them small. We want to make them small. And so a lot of these containers are being, put out there and using one core. And the consequence of that is you get a default usage of how garbage collection works that may not actually be appropriate for your project. So I thought this was a really interesting article. I need to read it more and get more down into the details, but I promised I would share it with the group because it's interesting information on the deployment side.
You do have one question, Melissa.
Words of wisdom for someone like myself, transitioning into the field of computer science as a student. You are doing the right thing today, coming to a meetup group. I think meetup groups are awesome. They really give you a sense of community. They give you the connections that you need to ask questions and to find mentors. That is going to be huge for you. A lot of this is going to seem overwhelming at first because there is so much to know. This industry is huge, so never be afraid to ask questions and keep your focus on one thing at a time. So whatever you're studying in at school, figure out how you can just implement that piece. Trying to spread yourself too thin to learn all the things, you're going to burn yourself out pretty quick. So just take it one step at a time. I know I felt discouraged. For a long time, I just felt like I was dumb. Everybody knew more than me. But it's not like that. It's everyone knows different things. And that's why these communities are so great.
Yeah. And I guess to add on to that a little bit, yeah, definitely take it one step at a time. Even it might take years to figure out certain things that others just intuitively know. So don't give up. At some point it will click, and definitely never lose your sense of curiosity.
Yeah.
Yes, that's really good advice.
Yeah,
really good.
and take advantage of Pittsburgh Java user group for sure. I mean, if Java is something that you are focusing on, come join our sessions. I actually just learn some of these things, or at least even hear the terms, even if I don't actively use it or don't use it. At least I'm hearing stuff, and then something sticks, something connects at a later point. I don't have to do a PhD degree in this, but I learned a little bit more about Docker, and it's definitely more than what I knew an hour ago. And that's good enough too, right? So take advantage of these meetup groups, especially Pittsburgh Java user group.
Some groups are better than others.
But we don't play favorites here, clearly.
We also have a YouTube channel. I think you should all, you can all see our sessions from 2021 and 2022, which also covers contents from like open source, future of Java. We did like a bunch of things like, I think microservices, all these things, they all connect in some form or shape. Hear it and see like what sticks, and then you can take it from there.
And we have a lot of like other talks from 2021 that were about Java, with Java 17 coming out. So there's a lot of stuff to learn there. I do have one more question. It's going to be about container market again, because I found that section really interesting. But whenever the graphs break down Docker versus containerd, so is the Docker portion that monolithic full stack version that you were talking about that Kubernetes will stop supporting soon?
Exactly.
Okay.
Yes, that's exactly what it is. It's full on Docker. Even though it now includes containerd itself, there was some basically some abstractions that were there that were only there for Docker. And Kubernetes, the group got pretty tired of just having a different set of connections for Docker specifically than for everyone else that was all following, the OCI specs and standards. So once they moved away from that, they pulled out containerd. Containerd meets all of those specs and standards, and that's what you would use instead.
Awesome. So yeah, we'll probably continue to see containerd growing in use over the next year or two.
Yep.
Cool. I don't see any more questions on the chat, but I guess, Renat, this YouTube video will be available in the next
few days.
In a few days.
Yeah, and I think Sarisha already pasted the link to the channel. So on top
subscribe
of
to it so you'll get notified. I can't believe I'm that person now who says subscribe to YouTube channels, but yes, do subscribe to YouTube, to this channel, so you get notified.
Oh, and don't forget to enter into the sweepstakes, right? So let me paste that link in again.
Yeah, yeah. Do you always choose bananas for this presentation, or do you change the fruit?
For this one, yes. And then there's another one that I do like different banana pictures that are a lot more fun, but yeah, I use bananas quite a bit. Can you think of another food?
No, I actually got distracted for a second there because I was like, what else can it be? A container? Yeah.
I did a talk at Open Source Summit, and someone interrupted me because it's a different talk, but I also used bananas. And he just said, I just want to say bananas is an excellent choice because that's what we would use when we weren't sure if like the fruit was clean. I could peel it.
Yeah.
It was somewhat protected.
But no, the bananas was an awesome choice. It was a lot of fun.
And it fit almost every slide. And I was trying to like figure out what you might say looking at the image. So it was fun. It was fun the entire time. I was like giggling away.
But it was a lot of fun trying to find like specific banana related photos or
Oh
pictures for
man,
certain slides.
you know, I stayed up very late.
I can imagine having to.
There was one night, yeah, I was just going through banana pictures. Yeah, pretty fun.
Anyway, thank you so much. That was entertaining, and we learned so much more about
Yeah.
Docker. So thank you. Thanks a lot for
Very
joining
welcome.
us.
Thanks for having me.
Of
Yeah.
course.
Thank you so much.
And thank you everyone for joining as well. We will see you all on May 12th. That's going to be our next session. So this is not our usual schedule. Like we typically do them on second Thursdays of each month, but this one, because DevNext has happened last week, we had to push this one out to this week. But so our next session will be on May 12th. Yeah, you'll get notified on Meetup. So
yep.
That's where we'll
June 9th after that. So yeah, a couple of sessions coming up.
Yep. Cool.
But yeah, thank you so much for everyone coming, and thank you, JFrog, for sponsoring us.
Yep. Thank you.
Yep.
Cool. See you all in the next session. Yeah. Bye-bye.
Bye.
Bye.
Bye.